Okay, welcome back. Next speaker is Laurent Castellan from UNOOS, UNOOSA, and then the UN Spider. He's online now. So, are you there, mister? Are you on the plane? Well, you said you're gonna fly back from Romania to Geneva or something. I don't know.
Hi. Well, you never know where I'm going, right? No,
Yeah, right,
I'm
right.
still in Romania. The plane will be tomorrow early morning.
Okay, okay, then we are safe.
Yes.
Okay, please share your slide.
Yeah, let me do that.
So you will learn what the UN doing about disaster. What can they do? And he's the man, so you can ask him. He's now the chief of Asia for UN Spider, and then Africa, I think, right?
Yeah, so we are distributed in 3 offices. I'll talk about it
Ah,
in my presentation, but currently I'm managing the Beijing office and also the Vienna office, which covers mostly Eastern Europe, some Africa, indeed. Yes.
okay. The floor is yours, sir.
Thank you very much. I hope you see my screen. I think I
Yes,
see.
yes,
Yeah.
we can see. Yes.
Okay. Let me just see. Good. So thanks for giving me the floor, Chai. I'm also sorry, of course, I cannot be there with you in person. That was the plan originally, that I will be also present. That didn't work out, but I'm happy to present at least remotely on the work we are doing within the UN when it comes to using space technologies for disaster management in general. So I will be talking about the UN Spider program. That's where I'm working, and hopefully after these 20 minutes, you'll have a better idea of what this is and what the acronym stands for. It's for some, it might sound a funny acronym, of course. Um, so just see if I can. Yes, what I want to start with always is put it space a bit in a context. We have when it comes to current space developments, there has been a lot of increase in activities in outer space. As you all know, the number of objects launched into space, number of satellites has been growing rapidly. We are now at over 6,000 active satellites, but I'm not even sure we know the exact number. And there's a lot of new constellations or mega constellations planned to come online. Of course, we also have challenges when it comes to that. Debris becomes an issue. Accessibility to space becomes an issue. Many states are complaining that sooner or later they will just not have any more access. There's no more orbit, no more communications frequencies available because of this big rush. And only some space might be advantaged over some countries might be advantaged over others in using space. So those are all challenges that, from a legal and policy perspective, our office is also called to tackle. Especially because we are also the secretariat for the United Nations Committee on Peaceful Uses of Outer Space. This is a committee of member states that currently about 104 states are members, that discusses these legal, political, and technological aspects on a regular basis as one of the UN main committees. The space economy is today valued at almost 500 billion a year, and obviously it's projected to increase. A lot of commercial activities are coming also in, and navigating all this and making sure that users have access to all the data, information, and products that these new space actors are all generating is a big issue. So how does this UN Office for Outer Space Affairs comes in? And I'm not sure many of you heard about it. It's one of the offices of the United Nations. We are part of the Secretariat, in fact, under the Secretary General of the UN. But we are a small office, and obviously few heard of us. We are working actively in bringing benefits of space to everyone. And as I mentioned, our main role is to be the secretariat of that committee on peaceful use of outer space, working with member states, international and other governmental, non-governmental organizations, implementing a number of activities, a program on space applications, the UN Spider program that I will talk more about with our 3 offices in Austria, China, and Germany, managing a register of objects launched into space. We have that online, and every state that launches anything into space should be reporting those launches to our register, which is then populated and available to anyone to consult. There's also an international committee on global navigation satellite systems that we are the secretariat of. This brings together all the satellite navigation providers to coordinate, look at interoperability issues, etc. And also more recently, we have this space mission planning advisory group. Given that complexity of launches and planned missions, a stronger need to coordinate has come up, and this group was formed within the committee. So as you can see, although we are a small office, there's a lot of different activities in the outer space domain that we are undertaking, and UN Spider that I will focus on is one of those many, but I would say an important one, given that the mandate comes directly from the UN General Assembly, so all the 193 member states of the UN. Our office, as I highlight here, works on all areas of sustainable development with these different programs that I mentioned. We are addressing a number of issues on the Sustainable Development Agenda of the world, the famous 2030 Agenda for Sustainable Development, and the 17 SDGs, as you might know. And as you see there, UN Spider is one of those blocks, the one related to disaster management resilience. But there's a lot of other areas where we look at how space can benefit society. What I always like to present is these 2 slides that are highlighting how the space environment has changed in the last few decades. This is how you would have seen Earth from outside in 1957, with one satellite up there, the Sputnik of the Soviet Union. And of course, when you move to 2017, just 60 years later, that's the complex configuration of satellites orbiting the Earth you see. And that is 2017. It was a graphic generated at that anniversary moment, 60 years after the first launch. But that doesn't include the hundreds of new satellites, Starlink, Planet, OneWeb, Chinese satellites in the hundreds that are being launched, that have been launched since. So obviously this is a very much growing scene and a much more complex environment that we have to make sure we tap into as resources, as data sources, and use them to our benefit. And then in parallel with that, of course, the trend in natural hazards over the last decades has been evolving. So if you compare the 2 decades from 1980 to 99 versus the last 2 decades, you can see a strong increase in the number of disasters, but also in the number of people affected, also because of the fact that population is growing. But the intensity and the number of those disasters, as they increase, they impact a lot more people. As you can see on the graphics, especially when it comes to flooding, storms, or wildfires, there's a significant increase. These are all, of course, climate-related disasters, but we have to take note, and we have to look at how we can address this challenge going forward. And that is the reason that member states of the UN have decided to establish the United Nations Platform for Space-Based Information for Disaster Management and Emergency Response. It's a long name, and that's where the UN SPIDER acronym comes from. And our mandate was very simple, ensuring that all countries have access to and develop the capacity to use all types of space-based information to support the full disaster management cycle. It's a resolution of the UN General Assembly that established us at the end of 2006. So we are operational since 2007. And I insist on the full cycle of the disaster management. Our support and these technologies are not only useful when we are responding, when we are reacting to a disaster that's happening, but in that whole cycle of looking at exposure, looking at risk, looking at prevention measures, being prepared, responding, of course, and then working on the recovery aspect. So there's a full cycle that we can address with using these technologies. Our program, as I mentioned, since 2007 has been very active, although a relatively small group of small team and limited funding. But we have been invited and visited a number of small island developing states and low and middle income states, up to 55 by now, in providing technical advisory support. 40 of those were very formal technical advisory missions that we undertake at the invitation of government, where we make recommendations. We submit an official report to government with our recommendations on what needs or what can improve depending on how they use these technologies. And of course, a lot more technical support and expert missions. As you can see on the map, of course, the coverage of that. We also support, of course, as we can, countries with data, training provision, funding, attendance to various workshops, trainings. Few of you in that room might be supported by us to be there as well. And when it comes to emergency response, we provide a lot of assistance, brokering access to satellite data or emergency mapping, and we've done that for over 30 countries so far. Our funding comes from a few countries, mainly China, Germany, currently, but in the past, Austria, France, Turkey, Japan also supported us. Japan is now starting again to provide support. We just received a junior professional officer from Japan, so we are very happy for that. The program works across 4 pillars. We manage a knowledge portal, which is about knowledge sharing and providing best practices, step-by-step procedures on how to use these space-based technologies in disaster management. And this is more to facilitate exchange of knowledge. Of course, we work on fostering cooperation, on strengthening capacity, and providing that advisory support that I mentioned. So these would be the 4 pillars of the program. What's more important is that we are small, we are limited in our capacity, but we have signed agreements with a number of what we call regional support offices to the program, which are centers of excellence in their own domains, geospatial, Earth observation in many parts of the world, as you can see on this map. We have space agencies, we have regional geospatial centers, regional remote sensing centers, universities. So a big mix of expert institutions that are providing in-kind support to us on an ongoing basis, joining us in our missions pro bono, or providing facilities for us to organize trainings, and so on. Some of them actually have quite good expertise in fire monitoring, and I know that some of you in the room might be interested in that. Our Greece support office, the National Observatory of Athens, is working closely with a number of countries and with support from the European Commission to develop the so-called Fire Hub series of real-time fire monitoring and forecasting. Very interesting applications that I can always share more information about with whoever is interested. We always emphasize that we are not only talking about Earth observation, but also about navigation, satellite systems, satellite communication, satellite meteorology applications. So when it comes to space technologies, it's not only Earth observation that can support disaster management. Bringing all these technologies closer to the user is our task. It's a big one and it's not easy, but we do our best. A lot is, of course, focused on Earth observation. That's easier, and that's what provides useful data very often. And of course, we facilitate a lot of that. I mentioned the knowledge portal just to give you a few points on that, and you see the web address there, and you can check out the website yourselves. This is something we try to also translate more recently into other languages. We have English, Spanish, and French versions available. We are looking into Arabic, Chinese as well. And then we have quite a large number of visitors. These are all mostly expert, specialized visitors, not general public, but as you can see, pretty well visited and known. And most valuable are maybe the step-by-step procedures to process and work with satellite imagery and the recommended practices for working with data. These are used by many people around the world to produce maps and to look at analyzing data. So we are very happy, and we wish we could do a lot more in that domain. We are engaged, of course, with a lot of other partners and external actors. We can activate the International Charter on Space and Major Disasters on behalf of any country or other UN entities. We can also activate other emergency response mechanisms, such as the EU Copernicus Emergency Mapping Service or Sentinel Asia, that you might be more familiar with. And we are closely working with the Committee on Earth Observation Satellites. In fact, I will be chairing the working group disasters, first as vice chair, and then as chair from 2025. So for the next 4 years, I'll be having a major role in coordinating disaster support activities within CEOS as well. And then, of course, we closely work with the Group on Earth Observation, GEO, and the UN Committee on Global Geospatial Information Management as well, GGIM. We have our own internal coordination mechanisms within the UN, a UN Geospatial Network, and the UN Space Interagency Coordination Effort. So this is to bring UN system entities on the same page when it comes to working with these technologies. This might be of interest to some of you. We worked hard in the past, and we continue to push private sector and donors to release a lot more data into the public domain, to provide more high resolution data for easier access. One such example is working, of course, closely with Norway, who then, as a result of discussions we had 6-7 years ago, decided to sponsor free access to weekly and monthly mosaics from a company called Planet. These are 2-3 meter resolution data covering the entire 35 north to 35 south band of the planet, mainly for forest monitoring. This could be also of interest to many of you, but also usable by anyone on a non-profit basis. And this was a major donation by the Norwegian government. And all that data on a weekly and monthly basis is available to anyone who signs up, covering much of the tropical region. And these are the kind of examples where major investments by donors in satellite data, in Earth observation data, leads to a lot of benefits also for all the users downstream. We are closely working with other providers and partners, and especially working with state and government operated sub-meter imaging satellites to increase access to those resources to the community, looking at signing various memoranda of understandings, etc. We were partners with Maxar, establishing the Open Data Program that you might have heard of, which is again providing free Maxar data for any disaster, major disaster. Maxar being the company that operates the highest resolution satellite imagery, imagery collection satellites. We have agreements also with Airbus for imagery and elevation models, and looking at partnering with other companies as well to advance this idea of free and easy access to very high resolution commercial data. We are also looking at working more closely with the China National Space Agency, because even to my surprise, as I discovered last year, there's over 100 various companies in China alone operating Earth imaging, Earth observation satellites, and that's very much an untapped resource for many of us, especially working in this domain of disaster management. So in conclusion, what I see here is that we are evolving quickly when it comes to satellite technology. Very high resolution imaging is still a commercial domain, so we have to work also closely with our commercial partners, private sector. We have to look at a lot more multi-user licensing and making data easier accessible and shareable between different entities. Working closely with those emergency response mechanisms, but also investing a lot more in being prepared for these mega constellations and this flood of information that's coming at us in the next years. So obviously moving away from the notion of downloading an image and working with it, but more into the domain of online analytics, cloud storage, applying machine learning, digital twinning, etc., to make sense and to exploit all this data that's coming at us in the future. What's important that this whole Earth observation and satellite technology domain is useful in a number of the global agendas that are on the United Nations priority. These are United Nations priorities, and for the entire world, the SDGs, of course, Sustainable Development Goals, the disaster risk reduction Sendai framework, set of targets agreed also in 2015, and of course the Paris Climate Agreement also agreed in 2015. All these global frameworks have a number of reporting requirements, monitoring, other obligations at national level, and indicators are there that measure progress, and many of these indicators are easier and maybe only able to be calculated with Earth observation data. That's why these technologies are so important. And in that context, we work closely with a lot of other partners to establish partnerships such as this multi-hazard early warning systems network to bring these technologies closer to the various users. As a last slide, I wanted to mention the Early Warnings for All initiative of the Secretary General from 2022, and some of you might have heard about it. Two of the UN entities, the Disaster Risk Reduction Office and the World Meteorological Organizations, are leading it. But the aim here is to make sure that by the end of 2027, which is very ambitious, all countries of the world have better access to early warning systems. And that's not going to be easy given the current situation that we also observe from all our missions. Obviously, satellite technology will be crucial when it comes to monitoring seismicity, landslides, earthquake, looking at data transfer, IoT, real-time data access, improving weather station distribution, all these different things. Without space technology, we will not be able to achieve these goals, especially not in 2-3 years. There's a large funding stream envisaged, hopefully coming in from the donors, and we are working as UN-USA to make sure that space technology is something that they seriously consider and invest in these next years, also in the context of this Early Warnings for All initiative. And I think I stopped there. It was a quick overview, but as I mentioned, I'm happy to give you more updates or details or links to some of these resources, FireHub and others. If you send me an email, my email address is there. I stopped there, and of course, I'm happy to take questions if we have some time. Chai, over to you. Thank you.
Thank you, Roland. We have time. Any question? for this. Yes, please. Okay.
Thank you, Dr. Zhang. Sorry, Loren.
Sure.
I'm one of those who got benefited from this UN Spider fellowships, attending this very workshop. Thank you very much. My question is somewhat weird. Please don't think otherwise. You know, drones is one of the novel platforms which are suborbital, but it's also giving its own advantages. Is in future you're going to have from UN a competitive or sister organization on suborbital affairs?
Well, okay, not not an easy question. Of course, there's a lot of these different domains and areas of work we should be more involved in, and as you say, drones are an upcoming in a way key technology as well. Many of our colleagues in UNDP, in World Food Program, and elsewhere are using drones on a daily basis, and of course, you know, at one point this probably might become more coordinated also within the UN. Currently, it's more about using the technology whenever is suitable. I'm a big fan of space technology, and I always how should I say, caution people that sometimes, especially over large areas, especially in major disasters, space technology is still a lot more useful to us, or faster in helping us look at damage and look at impact, because drones are very useful at a small scale, but it's not the same. I use the example of the big landslides we had in Sierra Leone a few years ago, when UNDP had drones available on site, and as soon as that major disaster happened that killed 900 people, I think in a matter of seconds, they were out there trying to, you know, map the affected area. But our satellite image, we were also lucky to get it through all the clouds and everything. But that satellite image, in 10 hours, the map of the disaster was on the desk of the vice president in 10 hours. So these are the, sometimes you have to look at, you know, what to use when, and all technologies have their advantages and disadvantages. I would say our office is mostly focused on space and anything related to space. There might be others who will look at more coordination and focus on, as you mentioned, suborbital or closer to Earth technologies. I don't see it being us, but I also see, I mean, it might well be possible. So I'm happy to talk more about it. I'm glad you made it there. I'm sorry we couldn't sponsor more. But time was a bit short, and at the beginning of the year, all our resources are also more limited. But those of you who made it, I'm happy you are there. So, and thanks for your question. Feel free to reach out for more on this.
Yeah. One more question, please.
Lauren, thank you very much for your insightful presentation. I am Sundar Sharma from Nepal.
Hi.
And further, thank you very much for having me in this very important meeting. It's not the question, but some information. ICIMOD and Department of Forest of Nepal has developed a forest fire detection and monitoring system. I think it is the robust system for Nepal regarding fire disaster, fire monitoring. And currently, ICIMOD and has added another fire outlook also for 2 days. It is very interesting regarding forest fire early warning system. The institution where I am working in is the National Disaster Risk Reduction and Management Authority. This authority is the government entity under the Ministry of Home Affairs, and the authority are now developing multi-hazard early warning system and risk communication to the local community. But the technological capability is, I think, very low. like the global south country like Nepal, I think the situation is similar to other country also. So in this regard, I can see there is a space and opportunity to for collaboration and support between national authority and the UN Spider to use the space-based technology for all the disaster cycle. Disaster cycle or Sendai or four pillar of Sendai framework. So in future, Laurent, I need your support for the future collaboration and future support. Thank you very much for your insightful presentations.
Thank you so much for the comment. And in fact, last year in January, I was in Nepal together with some colleagues from ESCAP to we provided the training for your colleagues at NDRMA in multi-hazard risk assessment, and we will be following that up in February this year with a training for some of the district disaster management experts that's being planned now. I think one hope was that it will happen next week, and that's when I was hoping that I can travel to both Bangkok and Nepal to be there. We had to postpone it, I think, for 3 weeks later now, and it's going to happen. And it's exactly about training in this multi-hazard risk platform that AIT and University of Twente, ITC in Netherlands have been developing. We are supporting it as Spider also financially, the trainings, and we would be very happy, of course, to follow up on the space technology side with you, and we've been in touch with Anil, your director, in the past, and I think if we get concrete requirements from you, then we can zoom in and we can improve our support. So by all means, just feel free to reach out. You have my email address anytime, as I lead also the Beijing office currently until we hire a new manager there. I'm directly responsible for support also in the Asia Pacific region, and I'm happy to engage. Thanks for the comment, and I'm sure we will be in touch.
Thank you, Laurent. Thank you very much indeed.
Okay. Any further question? Okay. If not, thank you, Laurent. Hopefully next time you can join again and support us again.
I hope so too. Thanks for the slot, and wish you a good debate there, and feel free to reach out anytime with any questions also after the class. So good luck for the rest of the days.
Okay. Thank you. Please, next speaker, Misura Kameya from the Ministry, Information System Division, Ministry of Agriculture, Forestry and Fishery of Japan. And he will give a talk about the recent policy and JICA's Green Asia project for the sustainable agriculture product in the Asia monsoon region. The floor is yours.
Somebody, Sawadee Cup. I said, yeah, I said Sawadee because I was in Laos. Yeah. Good afternoon, ladies and gentlemen. My name is Mitsuru Kameya from the Tsukuba Business and Academia Cooperation Support Center on behalf of the Ministry of Agriculture, Forestry and Fisheries. I'm glad to have the opportunity to make a presentation on the recent policy named Green Strategy of the Ministry, and some activities related to this strategy. Tsukuba Business Academia Cooperation Support Center promotes cooperation between industries, universities, and Agricultural Research Institute of the Ministry. Agriculture, Forestry, and Fisheries Research Information Technology Center, AFRIC, is an internal section of the Tsukuba Center who operates mapping. Mapping is the stand for the research network of the Ministry of Agriculture, Forestry, and Fisheries, MAP. My speech is composed of the items shown here. At first, general information on AFRIC for supporting agricultural research, including mapping. And secondly, I speak up about the MAP's ministry's policy, green strategy, responding to global issues. And thirdly, I'll mention about the green project to implement the green strategy. And lastly, I'll briefly mention about the new technologies catalog for sustainable food system in the Asia monsoon region. I'd like to briefly mention about the current service of AFRIC. This is composed of following 4 main items. At first, mapping and the research network of Ministry of Agriculture and Forestry and Fisheries contains mapping connects 72 locations of research institutes of the ministry, including the branch of the research centers. And the second one is the network service system. This is a basic network service for research activities with about 10,000 users. And most of the users are agricultural researchers. The third one is the scientific computing system. This is a kind of a supercomputer. This system supports the high-level research activities. And the network library system is operating an integrated database system named AgWG. This map shows mapping connects 72 access points of research institutes covering all the areas in Japan. The 5 research institutes, PRIMAP, NARO, JUCAS, FFPRI, FRA, shown on this slide covers 4 research areas of agriculture, forestry, and fisheries. PRIMAP is a policy research institute. It is located near the headquarters of the ministry in Tokyo. JIRCAS, Japan International Research Center for Agricultural Sciences, is located in Tsukuba, and one branch office in Ishigaki Island in Okinawa Prefecture. I will talk about JIRCAS later, but at this moment, I would like to add that JIRCAS has a liaison office for Southeast Asia in the Department of Agriculture, Thailand, and adjacent to Kaseta University. I'd like to add another thing. JIRCAS is often confused with JICA, Japan International Cooperation Agency, but they are different. JIRCAS is Japan International Research Center for Agricultural Sciences, and this is research organization. Mapping has been operating Mapping Philippine Link jointly with the Advanced Science and Technology Institute, ASTI, of the Philippines to connect with IRWE. IRWE is our International Rice Research Institute. This link has been also utilized by President of ASTI of Philippines. As I introduced at the APAN meetings in Nepal and Sri Lanka, the ministry promotes strategy Midori, green strategy. Midori means green in Japanese, as well as the digital transformation in agriculture. I'd like to speak very briefly about these strategies. The strategy Midori was established to respond various challenges in Japan, as well as to achieve the Sustainable Development Goals (SDGs) of the United Nations. This strategy would be comparative to the farm to fork strategy of EU and agricultural innovation agenda of the United States. This strategy covers a wide range of matters, including food, environment, and social matters. This strategy emphasizes the importance of R&D activities for agricultural sector innovations. The ministry also promotes digital transformation in agriculture. I had a presentation on this matter at Apan57 in Sri Lanka. The digital transformation covers production sites, food supply chain, and export, and administrative procedures of the central and local governments. By fully utilizing digital technology, various actors share data and make innovation to overcome various outstanding issues, as well as to create and provide values in response to consumer needs. Smart agriculture is also an important part of the digital transformation in agriculture. Smart agriculture refers to agriculture using advanced technologies, such as robots, AI, and Internet of Things. It contributes to the reduction of workforce, simplified information sharing, and efficient management in agriculture and livestock sector. I would like to emphasize that mapping supports these research activities to achieve the sustainable development in agriculture, forestry, and fisheries. The Asian monsoon region shares many characteristics with Japan, such as high temperature and humidity, especially in summer, and a rice-based agriculture, and a high percentage of small and medium-scale farmers. From this point of view, many of the agricultural technologies developed in Japan are supposed to be applicable to the Asia monsoon region. The ministry assigned the implementation of the collaborative research project to GIRCAS, Japan International Research Center for Agricultural Sciences. GIRCAS plays a core role in international collaborative research, and it conducts this project under the name of Green Asia. Utilizing the research network of GIRCAS, we will accelerate the application of scalable agriculture technology to the region and contribute to the transformation of food system in the Asia monsoon region. It contributes to achieving SDGs related to sustainable food production, food supply chain, and environmental issues. This slide shows that Asia monsoon region shares many characteristics with Japan, such as high temperature and humidity. It means FAMAW are tropical climates, and CFC is temperate, and A means hot summer and rainfall in summer. This area, and the green dot the shows the paddy rice farming. Yeah, and this blue line shows a small the smallholder farmers. So Japan is quite large here, and in many countries there are a lot of there are yes. Thank you. Yeah. Okay. Mm. Okay. Yeah. Oh, okay. I have to learn about how to travel. You can see, yeah, this is the Japan. Yeah, you can see China, Thailand. Thailand has a lot of middle or large scale farmers. But for example, Vietnam, India, Nepal share the same thing. The I think there are a lot of smallholder farmers. And this area, Asia Muslim region, embraces 44% of the world population and 9% of the world total land area, and 28% of the global GDP. And this area has emission from agriculture of the non-CO2 greenhouse gases. For example, methane and N2O, like this. Now, I would like to explain the outline of the Green Asia project. To coordinate the activities of this project, GIRCAS have established the international collaboration and the International Scientific Advisory Board for Strategy Middle and the International Center for Strategy Middle. The advisory board provide advice and comments to the activities of Green Asia project. And the International Center analyzes research results, identified scalable agriculture technologies for Asia monsoon, agriculture technology for Asia monsoon. GIRCAS uses the phrase scalable agriculture technology. This phrase means agriculture technologies that are applicable to wider areas. GIRCAS also conducts joint research with research institutes in the Asia monsoon region to accelerate the application of scalable agriculture technologies. The results of analysis and joint research are disseminated to the Asia monsoon region through international forums, shown here. The members of the advisory board comprise of outstanding scientists and executive officers from leading research institutes and universities who have in-depth knowledge of sustainable agriculture technologies in the Asia monsoon region and around the world. The members are expected to provide provide advice and comments on the research results, reports, and other outputs generated by the project. From Thailand, Dr. Pisamai Srichayet, she's the one of the board members, the director of the Institute of Food Research and Product Development, IFPRD, in Kaseta University. She is one of the board members. The first members of the advisory board was held in Tokyo as a hybrid meeting in October 2022, and the third meeting was held in September 2023. The International Center for Strategy Midori Green Strategy has been established within GIRCAS. The center serves as a hub for the collection, analysis, management, and dissemination of research results and outputs of the project. The newly developed website of the International Center provides a platform for information sharing. This website includes information on the advisory board members, reports, and other results that will be generated in the Green Asia project. Given the importance of the Asian monsoon region to the global economy, the success of sustainable food systems transformation has global significance. As the agronomic environment varies in each region, even in the Asia monsoon region, there is no one-size-fits-all approach. Fine-scale tailoring to locally specific contents is needed. And some practice developed in Japan or some countries could be applicable. Applicable to other countries within the region if modified for local needs. From these perspectives, Japan has a role to play in contributing to the region through strengthening networks among various partners and sharing science-based information that will be useful in and applicable to the Asia monsoon region. The basic agriculture technologies will be tested through international collaborative research. New Technologies Catalog version 2 was released in September 2023, last September. This catalog contains 31 technologies derived from the joint research results of GIRCAS and other related research institutes. This catalog is a compilation of applicable technologies which were developed in Japan or through international collaboration over the past 10 years and are expected to contribute to the establishment of sustainable food systems in the region. These technologies are for dissemination in the Asia monsoon region to promote the transformation in sustainable food systems. We hope that the catalog will serve as reference to various stakeholders in the Asia monsoon region, including government officials, researchers, extension officers, producers, and private sectors. We also hope that the technologies in this catalog will be demonstrated and implemented on the ground through optimization and coordination in various regions, thereby helping in transformation in the food systems among countries in the Asia monsoon region. These are some examples of the technologies shown in the technology catalog. So, international collaborative research activities has been conducted for applying and disseminating these technologies in more countries and areas. So it contains wide ranges covering agronomy or forestry here. Here. For example, identification of which species and provenance of timber to promote trade of legal timber, like that. And you can find fisheries. No. In detail, you can see, you can find from the website if you are interested. Green Asia report series introduces overview of scalable technologies that can be applicable to the Asian monsoon region and thereby contribute to the transformation of the region's food systems. Each report comprises of history and mechanisms